Hey guys, how are you? This is week of April 20th. All right. Our topics for this week are going to be looking at areas of triangles, but specifically using properties with special right triangles and also using some trigonometry. All right. Today's lesson, this first one, is just finding area of triangle using our special right triangle properties. So let's review special right triangles. We have two special right triangles that come up quite a bit. The first one is a 45, 45, 90. All right, so my 45, 45, 90 means that I also have an isosceles triangle. So that means these two, the legs, right, are the same length. So if this was 5, this is 5, and we know that the hypotenuse then would be 5 times root 2. And if I was given a 45, 45, 90, and I didn't have the two legs, all right, so let's, go back and let's change that. Let's say I just had a 8 root 2 here. Okay, so if I want to find the leg then, instead of timesing by root 2 to get to here, I'll divide by root 2. So 8 root 2 divided by a root 2 is going to cancel out that root 2. That would be 8, which makes that 8. Okay, so if I was going to find the area of just a 45, 45, 90, it could be very easy because, again, area of a triangle, base times height divided by 2. And whenever we're talking about area, we are wanting the base and the height to be perpendicular. Okay, so the base and the height would never be, say, this length and this length because they're not perpendicular. Okay, another name for height is the altitude. Okay, so whenever we're finding the altitude of something, it's the perpendicular distance to it. So the area of this triangle would be very easy because this is perpendicular, this is the base, this is the height. So I'd go 8 times 8, 64, but then I have to divide it by 2. All right? Okay. Other special right triangle is our 30, 60, 90, which is half of an equilateral triangle. So if I were to reflect this, I would have an equilateral triangle. So hopefully you remember the properties of a special right triangle that's 30, 60, 90. This is always, and whoops, you know what? Let me change those so it makes more sense with my picture. This is my 30-degree angle, this is my 60. I'm switching those around because if this is the smallest angle, this should look like the smallest side, but remember that's not always the case, okay? I might draw a picture that doesn't look right, all right? So if this is the 30-degree angle, if this is the smallest side and I call it A, you remember then that the hypotenuse will be double that. So this would be 2A, and the other leg is A times root 3. Okay. So if I had a 30, 60, 90, again, this would be the base, this would be the height. I would do this length times this and then divide by 2. All right. If I did not have those, so let's go back and say, I know it's a 30, 60, 90 because I can see those marked. If this is 4, then I know the smallest leg will be half of that. So that's 2 because to go to here I'd have to times by 2, so that makes sense. This would be 2 times root 3. So how would I find the area now? I would do area, that's perpendicular, so base times height, 2 times root 3, divide it by 2. I could cross out one of those 2's. It looks like my area would just be 2 root 3. Okay. Now what if so that was just a little review about the special right triangles. Now let's actually apply it to finding the area of a triangle. Specifically, let's look at an equilateral triangle. So if I was given an equilateral triangle, and this will relate to in the homework problems where you're finding the area of equilateral triangles. Let's say I have an equilateral triangle which means this is 60, 60, and 60. And I am given that one of the lengths is, let's say, 10. Okay, so that means this length is 10, this is 10, which makes this whole length 10 as well. But I want to find the area of the triangle, base times height. This is the base, but I don't have the height. It's not perpendicular. So I need to actually draw in the height. So my height's going to come down, boom, perpendicular. That means it just cut this in half. That's 30. That's 30. There's that 30, 60, 90. That's why we reviewed it. Okay. So 30, 60, 90. This is 10. This has to be half of that, right? So that's 5. I know that's 5. It makes sense because this has to be 10 to match equilateral. All the sides are the same. So this is 5, this is 10. That height must be 5 times root 3. Okay, again, special right triangle. Now I can find the area of that triangle. It will be the base, that whole length, which is 10. So I'd write 10 times the height, 5 root 3, divide it by 2. All right, now I'm going to have 50 times root 3 divided by 2. Again, I can cross cancel here. I'm going to get 25 root 3. That would be my area of that entire triangle. Now somebody else might say, well, couldn't I find the area of this right triangle, just this one? Yes, you could. Okay, so you could find the area of just this one. That would be 5 times 5 root 3 divided by 2. But then I'd want to double it because there's 2 of them. Okay, you can do it that way as well. So keep in mind, when I'm doing these problems, there's not just one way to do them. There could be multiple ways to do that problem. Okay. All right. That's pretty much on special right triangles. Now, finding the area of those equilateral triangles. Questions, come to the Zoom meetings on Mondays and Wednesdays. All right.